explain us like what he's capable to tell us, and can we learn from him. So basically, currently I'm mentoring startups as part of Government of India's program for Mentor of Change. It's a Government of India flagship program where startups and school students are encouraged to get onto entrepreneurship side. Apart from that, I mentor startups as part of eHub, Telangana government's technology hub, where they support startups where they are developing new ideas for betterment of the society. Apart from that, I'm part of United Nations Industrial Development Organization, which supports low carbon technology solutions, which help in reducing the environmental effects of different industries that currently are there in the world. Apart from that, part of Women Entrepreneurship, AIC Elite, and Balavikasa Social Entrepreneurship, and AIC Sangam, which is a clean tech incubator in Gurgaon. That's the social side of my work. But previously, before becoming a mentor, I have worked for different companies across the world. Starting with Caterpillar in US, I built many machines. I'll be showing in the next slides. I worked for Tata Technologies, developing machines for them. Infosys, developing planes, and my education has a Master of Science in Mechanical Engineering and Bachelor's from CBIT in Hyderabad, Chaitanya Bharati Institute of Technology from Hyderabad. So that's kind of like my little bit background. And currently, as I said, like I'm the founder director of Badagharwala Technologies. The company works in the sector of product development, basically on the hardware side, hardware of physical products, and sector agnostic. Like it's not any particular products we work with. Any product from idea stage to all the way to market ready is what we support. Apart from that, we're developing an edtech solution for students starting from classes 5th and above, training them in 3D modeling, not just learning the tool, but the application side of 3D modeling, like how 3D modeling can be used for learning maths and science and apply it for developing different products. It's an example of like how a class 6 student has developed using the geometry concepts, different toy designs. I'm just showing that example. So my company develops those solutions also. Before becoming mentor, these are some of the examples of machines I have developed in my past professional experience. Some of these machines are widely used in mines and landfill compactors. Shinra is a complete machine developed in India for Indian usage and other countries also. Been a program manager for that. As I said, like I mentor startups and students, so these are some pictures from those sessions. I'm a hands-on engineer. I like to dirty my hands and learn from it also and develop products. So these are some of the pictures from that. The list of all companies and colleges and universities have been associated with mentoring startups, students, and whatnot, like faculty. So there's quite a bit of work have been done in the past 3+ years. I've been mentoring and associated with different incubators, accelerators, colleges, and whatnot. I have innovation side also, like I have done innovations part of Caterpillar work I have performed in US. So there are 3 or 4 patents currently. There's 1 international patent granted and 3 in the publications currently. So with that in background, I just wanted to give a background of mine because so that you understand, like I have some experience of how products are developed across the world and in startups and also in colleges and how it should be done. But the current scenario, based on what I have observed and the survey we have run, as mentioned in the invite also, currently what is happening is like a student or a faculty or any innovator, he comes up with an idea, thinking that that will solve some problem, and he or she thinks that that idea is the best and something should be done about it. So what they do is like they take that idea and they start building physical prototypes. So they build one physical prototype, they learn something out of it, then they build one more prototype. These are all physical prototypes. They make a version 2, 3, 4. In some cases, I've seen like 4, 5 different physical prototypes are built. And then they start testing it as the physical prototype is built. They test it, but they realize at the end that the product did not serve the purpose. The prototype that they built did not serve the purpose because he did not test every condition possible that the product will go through. So what happens at the end is all the resources are spent, like money is gone, your time is gone, and there's so much of pressure on you to perform and show the final product output. But since you have lost your time and money, and huge amounts of in some cases we have seen like people have spent anywhere from 20 lakhs to 30 lakhs just for building prototypes and testing it out, and taking time anywhere from 1 year, 2 years, or sometimes like three plus years also. So by doing this, what is happening is like you are not meeting the customer requirement. First thing, there are huge amount of product performance issues. The product is not able to perform to what the customer is expecting. You definitely have exhausted all your funds. This is like 95% of the cases we see this, like they exhaust all their funds because they have spent so much time building the prototypes. And there's so much expectation now, right? So your family is expecting that you will have a product out, you might have done it, but there's no product available, it's just a prototype stage only. And finally, even after building so many prototypes, your product is not validated to perform the way it is supposed to do. So finally, building a physical prototype in the surveys and have come across different startups and innovators, it just did not work out. It just so many failures are there. So what is the solution for this, right? So if the physical prototypes are not helping us, then what is the solution for that? I'm just showing a picture of elements of a product development, what you should go through actually before a good prototype can come out or a good product can come out. I'm highlighting 3 areas which are kind of the key sectors you will be working in the initial phases. So when we talk about ideation phase, right, that's when you will do your customer surveys and understand like what problem you want to solve and what solution you should be working on. You will do that, you will do some market studies, you will take some customer feedback, and we'll make something called proof of concept, which is like a very dirty way of checking like this solution, what you are thinking about will work or not. It is not a prototype, a physical prototype, but just from the technology point of view, a proof of concept, which you will evaluate to see if the solution, what you are thinking, will actually work or not. From there, you will divide into 2 areas. One is the engineering side and the other is the design side. Engineering is more like technical part. Design is more like the view, the outer look of it, and how it performs. So engineering side, should start the first step should be your requirements and technical specification development, which is in simple terms is like what you are going to give to the customer. Simple example is like a car, right? So if you are developing, let's say a car, at least the customer expectation is that you will say him how much is the fuel consumption. That at least should be given to him. That's our technical specification, right? So those things should be documented and a document should be made. That should be a first step. Before even starting doing anything, it should be written on paper, like what technical specification you are going to give to the customer. Later you will get onto the technical side, like doing component calculations, which is all technical, building bill of material, initial bill of material, doing systems engineering, and then doing virtual analysis and software development or firmware development as required. Some of these steps may not be relevant to some startups, but most of the cases, since we are on the technical side, I believe like most of this should be applicable. I'll be showing some examples where some of these steps may not be applicable, but most of the cases this will work. Definitely your requirements and technical specifications should be there. Any product you are developing, it should be written. Then you can use your virtual engineering to develop those products. I'm not going to detail into the next steps because at this stage, you should be more focused on the first 2 stages, ideation and engineering and design. Later, once you have done your virtual engineering and virtual modeling, then you will go to prototype building, not before these steps are done. If you have completed your engineering and design steps really well, you should have your product up to 70% ready with you. That's the expectation of the virtual models. You should have a very clear idea about how your product is performing, how it will look like, and what performance it is going to give. All those things are possible if you have done all this in engineering and design phase. The point here is, till that phase, you have not spent any money to build a prototype. All these things are done virtually, on paper or on computer. and you'll be using the tools which I will be showing down slides, like what tools can be used and how they are available. And the options I'm going to show you, they are all free of cost. Nothing is like you have to pay and use it. So once a prototype is built, you will go for verification validation, which is nothing but testing. Then finally the government certifications as applicable to the product. And finally you go for batch productions or mass productions as the case might be for the product. So basically what I'm showing on the screen is a run through of all the steps that usually are part of a product development, right? So if it's a physical product is there, what steps you should at least go through before your product can be have a good market reach. And there are some points on the sites which says about customer feedback, supplier engagement, build, measure, improve, and design, build, verify. These are the things which will happen as you go through each step of product development. It should happen, like you should take customer feedback all along when you're developing your product. At every stage, including engineering, design, prototype, and validation, you will engage the customer to get his feedback. If your product is getting developed in a way he needs it, not based on what you want to give him. And supplier engagement is also required, because eventually whatever design you are making, he should be able to make it, right? It is designed for manufacturing and designed for assemblies, right? So those things are very important. So you should make sure that whatever design you are making, you get feedback from the supplier and make sure they be able to make it in the real world. So with that mind, I'm just going through one of the key stages, as I mentioned, the specification and requirements development. It usually includes what is a target specification you are planning to give to the customer, which in simple terms, as I said for the car example, how much is the mileage that vehicle will give. Same thing for your product also, like a drone, right? If you're developing a drone, what is the payload capacity that load can do, or what is the wind effect that it can take care. So those things you will at least specify to the customer. So if you go and buy a product online also, it will give you all kind of technical specifications, right? Like what parameters this product will give. So all those things is what we are talking about in target specifications. Second part is the requirements. These are nothing but the government regulations that will mandate you and the product to meet those requirements, which could be anything about safety, environmental issues, or overall dimensions of that product, or it could be anything else, right? So all those things which are required for the product should be documented upfront, and that should be part of your requirements. Third part is the features. Features are nothing but the additional things you are giving to the product which will make your product stand out in the market. Let's suppose there are drones in the market now, right? So many drones are coming out. So how is your drone different from the existing products in the market? So those features, what you are going to give, which will differentiate your product from the existing products, is what we will define in the features. The fourth point is the competitive benchmarking. Always make sure that we always think that our product is the best, there's nothing else in the world, but there is always something available which may not be exactly the same as what you are offering, but it will be pretty close. So it is highly recommended that you do a competitive benchmarking to understand what the other people or other companies offering and how you are different from it. So you should document all those parameters which the competition is giving to the market, and you document based on that. Last but not the least, this warranty and reliability. This one thing I have seen in particular, which is definitely missed by many startups and also many student innovators also. Warranty and reliability will make or break a company easily, because warranty is a loss for a company. If any warranty issues come, you have to pay out of your pocket, right? In the warranty period, if any issue happens, you are liable to pay it back to the customer, which is a loss for you. So understand what your product will perform and how it will perform and for how many years it will perform in the specifications what you are telling to the customer, so that you don't have to pay the warranty issues. Those should be done upfront to understand what is the life of your product, which is nothing but the reliability calculations and all. All these things are possible to be done in virtual world itself. Like virtual analysis you can carry out. There are equations and there are tools to estimate those warranties and reliabilities. due to lack of time, I'm not going to go detail into it, but I'll be more than happy to answer those offline. So basically the point is, warranty and reliability is a big factor. Please ensure that whenever you are developing a product, the warranty and reliability are understood really well, and understand the life of your product, and based on that, give the warranty period that your product can perform well. So the extract of all these 5 factors here, it could be some other things based on what product you are developing. Finally, you will come up with the technical specifications for that product. Technical specification is nothing but what kind of components you are going to use to meet above requirements. For example, like we talked about fuel consumption, right? So which kind of engine will give that kind of mileage should be known based on what kind of engine you are going to select. So those things will be defined in technical specifications. These technical specifications are your in-house numbers. These are not specified to customers. You will do it in-house when you are developing the product. Any questions, please put on the chat. We'll take it at the end, and I'll continue with the presentation. So we talked about the requirements and specifications. The next part and the importance of it. The next part is the CAD part, right? So we're talking about the virtual prototyping and all. And CAD is one tool which will definitely help you, and it is helping a lot. A lot of startups and companies are using it in and out a lot. I will show you a lot of examples to understand that. But the point is, computer-aided design, it could be a new thing for you, for some of you, I believe, but it is not hard to learn. It can be easily be learned and can be used for you a lot of advantages. Suppliers and customers and understand how the product is actually developing, can it be made or not, does the customer like it or not. So those kind of feedbacks can easily be done using 3D models. If there are multiple teams or multiple people working on the design, you can easily collaborate and understand what component he's working on, what component you are working on, how they will assemble together. If there are interference issues are there or any issues are coming up, you can discuss and resolve them upfront. Service and assembly audits can easily be done if you are using 3D models. We have done, like now, augmented reality and virtual reality is so much coming up, right? We have used those tools to understand, can a product be serviced and assembled easily or not, using virtual models only. So that helps you understand, like if there is any service issue comes up later once you make a product, those can be understood upfront. And these models go as an input for virtual analysis, which we will talk in the next slide. So basically, if you are running any analysis, these 3D models are used as input, and you can run the analysis on those. So basically, there are quite a bit of advantages using these models. You may feel like I'm showing examples of car, that these are useful for only big components or big products only. Believe me, it is not the case. I've taken this example just for visualization purposes only. But any small component, single piece components can be done. I will show you some examples later. Can be done using this kind of modeling. Next part of the virtual product development is the computer-aided engineering. This is purely analysis tools that are used to evaluate if your product will work and perform in the way you want. And it will also check the material required will sustain or not, what kind of performance issues degradations will come, all those kind of things can be done. I'm showing examples of drone here, where structural analysis was done using CAE tools and flow analysis using CFD tools was done to understand if these structures will actually sustain the loads these drones will go through. And the wind effects that are there in the atmosphere, will this drone will actually work or not. One more advantage, the major advantage that we see using these kind of tools is you will never be able to simulate all kind of boundary conditions your product will go through. For example, like let's suppose you are developing a product in Hyderabad where the atmospheric conditions are different, whereas this product is supposed to work in Himalayan conditions. You have to spend a lot of money to simulate those conditions if you are doing a physical prototype. For example, like if you want to simulate a minus 10 or minus 30 degrees centigrade, let's suppose your product is supposed to work in those conditions, then you have to build a complete chamber which will reduce down to that minus 30 degrees centigrade, right? If a product is small, you will be able to do it. If the product is large, then you are building huge amount of investment to build that kind of environment. But CAE gives that possibility for you to simulate those conditions virtually and understand how your product will perform. So just a small example, but cases like that can happen really well. For example, like drone also, right? So if you are simulating wind conditions, which is like typhoon conditions or cyclonic conditions, and you want to see if the drone will work or not, you will never be able to do it in the real world, right? So it's very hard and in some cases impossible actually to take your drone out and test in cyclonic conditions. But those can be simulated easily sitting on your computer and running those analyses. So that's about like the tools and options, right? So I just want to show you some examples how we have actually performed in the real world and how startups or companies have utilized these tools to develop the products. One of the example is Blue Power. They make something called turbines, which are basically for decentralizing power generation. These are used in northeast area of India. So we developed a complete CFD model for those turbines and ran multiple iterations of designs with the CFD for analysis, computational fluid dynamics using Fluent as a tool. And just based on virtual models, we were able to get social alpha, they were able to actually win the social alpha challenge and got funding to develop the physical prototype. The idea here, or the point here I'm trying to make is, it's not required always that you should have funding to make physical prototypes. Just based on virtual models, you can get funding if you have done your work really well. And this is one core example that we have done. This product is now in the market. Anybody wants to check out, there's a website bluepower.in. You can go and check out how they are doing it. Just not startup, there are large companies, corporations like Caterpillar, I told you, this is an MNC company, Fortune 50 company, developing large machines, small machines for different applications, which are used in mines, landfill compactors, or trash applications. This one particular machine which I'm showing on the screen, 992K, before virtual prototypes, they used to build actual prototypes in physical world, and it used to take 4+ years to develop this machine. And now they have moved out completely out of this kind of system, and they are working on the virtual world, and they are developing machines in less than 18 months, anywhere from 2 years to 18 months now, which has significantly reduced their time, their money, that is investments that are required, and they have validated their products really well, and they are performing really well and making huge profits also. The idea about showing this product is, this model has more than 2,000 parts, and all these parts were put together in a virtual model and built as a complete machine, virtual analysis done, and directly taken to production in some cases. In some cases, we did not even build prototype, we have taken directly from virtual models to production cases also. These machines are huge. I just give an example of JCB. We all know that they are used in road construction application. It is about 75 horsepower, whereas these machines are 900 horsepower machines. So engines are like huge. The sizes are huge. The tire sizes are anywhere from 12 feet to 15 feet diameters, and the loading capacity, the amount of load that it can lift is anywhere from 20 tons to 25 tons, depending upon what kind of bucket we are using. So the huge machines. It's not that virtual analysis is done only for these kind of applications. We have also done a very simple single piece product. This is a product for making cow-based diyas, which are used during Diwali and other festival cases. So there is a Goshala which is trying to build a mold from which we can make these kind of cow dung-based diyas. But before that can be made, we have to make a mold which can give that kind of output. So first start, we wanted to see what kind of diya design we need. So we made all virtual models to understand what kind of diya design will make sense and meets the requirements of the customers. So we have different iterations were made all virtually, and iteration 5 had given us a final design which suits the application what we are looking at. So basically, we wanted to see like what is the depth of the diya, so ample amount of oil can be poured in it, and the batti or the lick that we put there will sustain and stop and will be holding there. So once those designs were really well, then we made a 3D print of it to see which physically how that finally came out, and now the next step will be to make the mold of it. So it's not that we always do very high-end products. Virtual analysis, virtual product development can be used for simple applications like this also. It's not that we always have to do very complex products only. So this is one of the grassroots innovation that we did. So all that is good, but there are certain advantages and disadvantages, right? There are some challenges that we face. So till now I told everything like so great about virtual modeling and all. But there are some challenges also. It's not that virtual prototype doesn't have its set of challenges. I will not say that everything is great about it. But yes, there are some challenges. One of them is it depends upon the validity of the product that you are building, depends upon how good you have built the model also. So the virtual model that you are going to build, if it is not built with high fidelity, then the output will also be not good. So it's basically like the better the model will be, the better output will come. The second challenge that we usually face is some of the tools that we use for analysis in particular are very high cost. For example, like CFD analysis, right? So it is very, some of the licenses are very expensive also. So how we deal with it? So I'll show you some examples of how it can be done. And some cases, you need to have very deep understanding of the tool itself. Like when you are running, especially the crash analyses or some very high-end, or even the CFD analysis, you need to have a deep understanding of the tool itself. So that is one challenge that we usually face. CA analysis, which is a computer-aided engineering, resource intensive. Like you need some high-end computers, like high-end CPUs and very good hardware to run these models. And incorrect boundary condition setup. So it's all about like what output you get is based upon what input you have given, right? So if you are given input as wrong, then your output will also be incorrect. It's basically a garbage in, garbage out case, right? So you need to be careful about how you are setting up the model and setting the boundary conditions so that you don't get some results which doesn't make any sense. So these are some challenges, but they can be resolved taking some help or understanding a little bit about the tools. So those were options and challenges, but I'm here sharing some of the tools and resources that you can right away use. And all these options I'm showing here are free for use, no need to pay or take any licenses required. The first tool is Blender 3D. Blender is a 3D modeling tool basically used for marketing purposes. This is not for making a product for technical cases. Blender is more like for VFX or marketing presentations or animations, that kind of stuff you can make in Blender. So basically you make your model in another tool, you shift that model into Blender and make cool animations for your marketing purpose. That would be a better use case for it. Second tool is Fusion 360. Fusion 360 is a complete technical tool for making technical prototypes of virtual prototypes. This tool is again free for use. They give for 1 year free use for your evaluation purposes. Once you are into commercial application, then you probably have to buy that license, and the cost is way low actually. Fusion 360 for 1 year is fine, and startups can use for 3 years also. So there is no restriction as such. So as long as you are a startup for at least 3 years, they give it for free. And if you are using for learning purposes, you can use for personal case, personal use, and it's for free. But once you are in the commercial space where you are selling your product, you better buy the license, which is about 16 to 18,000 per year, which is way low than any other tool in the market currently. Even including SolidWorks, PTC, or the Pure, or even UG, any tool compared, this will be like the best choice you would have. I'm not a like influencer for Fusion 360. Don't take it that way. I'm not trying to sell you the tool. I don't get any cut or percentages out of it. I'm just showing you the options. None of these I'm promoting. This is my personal experience working with these tools, and how startups have get benefited using these tools. Design Spark Mechanical is another option for making 3D models. Fusion 360 would be the first choice. Design Spark Mechanical is the second choice I would go with. If in case Fusion 360 doesn't work for you, then you can think of Design Spark Mechanical. The next is Tinkercad. Tinkercad is again a website-based. This is like web-based tool. No need for any installation or anything. You can do 3D modeling. Not a great thing for 3D modeling, but it is good for digital electronic circuits and coding. If you are building any digital circuit for your firmware, any of your IoTs or drones, this tool could be a very good help. Alice Vision is a photogrammetry tool. This tool is nothing but if you have an existing product and you want to make a 3D model of it, you take pictures of that model and you reverse engineer it to make a 3D model. And this tool is the best for that. Let's suppose you have an existing product, but you want to modify it, but you don't have a 3D model. Then you take pictures of that product from different angles, you upload it to photogrammetry, the Alice Vision, and you use a technique called photogrammetry and make a model of it. So that's Alice Vision for you. BioBlender is more for like visualization of proteins, or more like a chemical chemistry-based application. I'm not sure how it will help in the product, but this could be something you can explore again for free. Some tools I want to show right over here. One tool will be very helpful for you. That is called McMaster Car. This tool shows all the hardwares that we use, like bolts, nut, washers, and whatnot, right? So all these things are listed here. You can just click on those product and select which system of measurement you want to use, metric or inch based, and it will show up all different types of options that are available. This particular thing is very important for you to understand, because I have seen cases where innovators have used hardware which is not available in the market. They directly go and use something which we have to import from China or some other country, which ends up very expensive for you. And the product cost the hardware cost is in some cases higher than the overall product cost. So they have done that kind of things also. So better to understand what are the options available for you. Does it fit in your product? And this McMaster Car does also give a 3D model of that particular hardware that you are going to use. You can just click on this 3D and this part number, and it will give an option for you to actually download a 3D model of it, which will definitely help you to understand how that hardware will assemble in your overall product. So this is McMaster Car for you. Next option of tools that you can use is this weatherunderground.com. All these presentations will be shared with you. No need to just note it down. I'll share the presentation so you can have all the links and details about each of them. I'm just showing you the options. So when you are running your product validations, you want to have something called weather information, and you want to have some historical information also, like what has happened in a particular place, what kind of temperatures and wind conditions you have seen or pressures you have seen. So you want to know that. So you can get those historical weather information using this weatherunderground.com website. It gives anywhere back to like in some places up to 30, 40 years back also, and that should be enough data for you to do analysis. So that's for the weather data. As I was saying, Blender, it's a free tool, rendering, modeling, sculpting. There are multiple things you can do in this tool, and it is free for installation. It has to be installed, but it's for free. That's Blender. Fusion 360, as I mentioned, it gives option for you to design multiple things. You can have the US, this right now, India side. it will give all the options for you to develop your product. Again, this needs to be installed. It can't be done without that. And one more option for models is grabcat.com. It's basically a library of 3D models that you can directly download and use it, or at least learn from it. There are multiple options, like you can basically drop down and select what kind of product you want to use. What is cool about this is, let's say, like if I want to know drone, what components are there, you can open a 3D model and explore it and see what are the components inside it. So if I go to this 3D option and load in 3D viewer, you may ask like how this is useful for me, right? So basically, when you are developing a product, you want to see what others have done and how they have developed it. And you can just open the model and see it. Otherwise, you have to buy the product and see, right? Instead of that, you can open a 3D model and see what product parts or products they have used. You can zoom in and check the dimensions also, like what dimensions they have used and what you can start with. So basically, it will also help you to start also, right? It's a kind of a jump start. Like you don't know what dimensions to start with, you can measure here and take it from there. So that's how this GrabCAD option can be used. And there are other websites also, like Purpose Squared, which gives the models and the 3D and multiple of them. But I particularly like the GrabCAD because it does give these industrial products right away to you. You can take sections also to understand how the product looks like from inside out, and it will show you this thing. So I think it's pretty cool, and we have used in multiple cases to understand how others have done it, what dimensions we can use, and what are the distinct parts. And one more advantage of this is some of the parts which you don't design yourself, like for example the motor in this drone, you can directly take the 3D model from this and use in your product. Instead of making it yourself again, you can directly take it from this particular model and import it into your model and build your own product. So that's another advantage of that. Another cool website that you should be using is whenever we are running analysis, right, you need material information. Right? So there is one tool called one website which gives that information, that is macweb.com. It gives all your information in terms of physical properties, mechanical properties, and thermal, electrical and thermal, which you would definitely need to compare how your product is performing with that kind of material, right? So, and you can, one more advantage of this particular website is you can directly download these properties in an Excel file or export it to a 3D modeling tool and use as input. And it gives a lot of cool information that is used, and we have used extensively worldwide for different products, and it did help us a lot actually. And whatever tools I'm showing, these are definitely used in commercial applications also, and not that it is just for some research purpose. And it has been used for commercial applications, and we have benefited out of it, and quite a bit actually. Another tool that might be of help for you is when you're developing circuits where you don't want to buy ICs and all expensively. There's a filestat.com website where you can simulate different circuits and see how the performance is. So there's one tool for that, and another is a Tinkercad, as I mentioned earlier also. You can physically build, instead of buying the Arduino Unos or Raspberry Pi, Arduino Uno is inbuilt. You can simulate different conditions, different setups, and see how the performance is. And they have inbuilt voltmeters to see how the voltage usage, everything can be understood in the virtual world itself. And finally, it gives a layout also of the whole setup, which is like even more beneficial. And the third part of this is it does have coding also. So you can set up different conditions and see how the overall circuit is performing. One tool I want to show you, last but not the least, is a CAE based computer aided engineering, which is called SimScale. This is particularly useful for running analysis for your product. There are two things into this that needs to be understood. This is a free tool as long as you are in the community. And one more thing is, when we are doing CA analysis, it's always need a lot of CPU power, right? And RAM to support the analysis. SimScale takes that issue out. It is all web-based, and they do it everything on the cloud. So you select how many CPUs and what RAM you need and what you, and it will simulate that conditions for you, and you can do all on the web-based application itself. So you need not have to install any expensive tool, you need not have to buy licenses, just do it virtually. The only flip side of this tool is, what I would suggest is, when you are doing your own product at the final stage, buy the license at that time for the SimScale. Don't buy till that time. Do all your basic simulations for free. Later, when you are at a stage where you are about to go for the commercial or final product, then buy the license. Okay, we already talked about it. Weather underground we discussed. So basically, it gives this kind of information. It gives a summary of that location.
Hello.
Yeah.
Can you please repeat the previous tool which have been stated now?
SimScale, right?
No, sir. Before that.
FalStat.
Yeah.
So FalStat is more like circuit building, right? So instead of buying the expensive all the circuit parts and all, you do it virtually, either using Tinkercad or FalStat. You simulate your circuit and see the performance and learn about different parameters of the circuit. So that's what this FalStat, which is all online again. FalStat and Tinkercad is online, web-based. You can set up your circuit and see how the performance is. That's what it is about. Any particular question you have about it?
No, sir, nothing like that. Only this one.
Explore this. I mean, see, I'm just showing it high level, right? Open this site and see how it is working and how you can use it. Any questions, just shoot me. I'll share my information anyway.
Yes.
Yeah. So that's the weather underground. It gives by month and by date, each day what was the maximum temperatures, humidity conditions, wind speeds, pressures, and precipitation conditions at that particular area. So I've taken this for June 2012, 10 years back for Secunderabad area. What was the max temperatures that we have seen? And I can use this as input. It will give, the output will be in the form of Excel that I can easily copy and paste in an Excel file, and I can feed that into my analysis tool and simulate it to see how my product will perform in these conditions. So that's weather underground for you. McMaster car we discussed. So pretty much at the end, about 15 minutes for you for questions, but that's pretty much I had for today. The conclusion point I did not write here, but what I want to tell you is, instead of going for funds right away, use virtual analysis for your benefit. Use virtual tools that are available. Build your technical requirements, product requirements document clearly upfront. Understand the product from customer perspective. Then go for asking for funds, because currently funds are not available right away without having proven prototypes in the market, without any customer validation done. So the suggestion for all of you, please utilize these tools for your benefit, learn from it. If there are any challenges in terms of how to use those tools, there are huge amount of tutorials available, a lot of YouTube videos are there. If not, you can reach me at any point of time. These are my coordinates. You can email me at manoj@bwtech.com or call me or WhatsApp at the same number 9642038383. I'll be more than happy to help you. So let's take some questions if you have any. Let's see. Yeah, there's one question from Vishwat Sen Reddy. I have a question about the Diya model you just showed in your presentation. How did you know that the temperature of Diya won't break the model? Yeah, see, the plastic model was to understand the physically how it will look like. We are not making plastic Diyas. The diyas will be eventually made of cow dung based powder. It is not finally it is not made of plastic, so there is no problem about like it will burn down or something. The cow dung powder itself, we can use diya for 3-4 times. It will not run. It will not work more than 5-6 times, I think. So before lighting it up, what they do is they dip it in the water for a second and then they light it up so that the diya will run. The idea here about that cow dung based diya is it's a self-sustainable solution, right? So once you use that diya and it burns down, that ash is used as manure for the plants. So eventually that manure is getting used by the plant. So that's the whole idea about it. Any other questions? Okay.
So no questions from participants. So we have added most of them in a WhatsApp group. If at all any further queries they have, they will try to reach out to you.
Sure, sir. And I will share this presentation to you. You can share it to the participants.
Yes, definitely. Okay. So I have shared the feedback form link in the chat box. So participants can share their feedback using this link. Manoj, I think we have one query from Mr. Anil Kumar.
Yeah, to get customer validation regarding visual aspects and getting okay in visual look, yes, you are right. The touch and feel factor, most of the cases, depending on the product taken, right? So that question, of course, is valid. As I mentioned in my presentation also, like 70 to 80% of your validation does happen on the virtual model. This touch and feel factor, as I mentioned in the initial slide, like the steps of product development, you will always keep your customer feedback going back and forth while you are developing the product. So one of the cases when you are into the virtual world, you will do, not virtual, but the actual design phase, you will make a prototype where you will just check the feel factors or touch feel factors. In that case, you will get these kind of feedbacks. Virtually, you're right. It will not be possible to get that kind of feedback. I hope that answers your question. If anything else, you can always take offline. Thanks. Any other questions or any concern? Or anybody wants to share something, we're more than happy to do that.
Okay, so with this, we have come to the end of the session. We'll conclude, Manoj?
Yes, sir. I think there are no further questions, so we'll conclude here. Thank you, participants, for holding on to my presentation and listening through. I'm sure there are a lot more questions you might have, but as I mentioned, you can always reach out to me. I'll be more than happy to help you out and review your product in case you want to review it also. Thank you very much.
Thank you so much, Manoj. So once again, on behalf of Osmania University and Osmania Technology Business Incubator, we would like to thank you for spending time with us in this Tech Talk. I'm sure the participants got benefited with the knowledge that you have shared. So this session is also streamed online on YouTube. So the participants who missed to attend can watch it on YouTube. So our CEO, Dr. Zaharullah, couldn't participate today, but he has conveyed his wishes to you and all the participants.
Thank you, sir. No problem.
So with this, we conclude the session. I once again thank all the participants for attending this session, and I look forward to see you all again in the next Tech Talk. So thank you so much, and have a good day.
Thank you.